Hey guys, and welcome back to another video. So, a while ago, one of my subscribers on my channel commented saying that I should make pure silicon dioxide, from sand, by first taking the impure silicon dioxide, which is sand, and converting it to sodium silicate, then to silicic acid, and then back into silicon dioxide. And I did some research on this and found it to be a totally viable method, so that's what we will be doing today. So, what I have here is just a fair amount of sand. It doesn't really matter how much you use, but it's just from the beach, and it is wet, but that's okay. We also need some hydrochloric acid. This is muriatic acid, which we picked up at Home Depot. And this hydrochloric acid is first going to dissolve any impurities such as iron oxides and calcium carbonates from seashells to make our sand a bit more pure before we go ahead to the next step. So, what we first must do is totally cover this with hydrochloric acid. So, we've got our sand here. Just open up the hydrochloric acid and pour in a copious amount. We are going to want a large excess because we want to get rid of as much as possible of the impurities before we proceed to the next step. So we'll just let this sit for a bit to make sure everything dissolves, and I'll meet you back tomorrow after this has sat for a good day or so. So after acid washing for about a day, I took it out, poured off the contents, and washed several times with water and decanted off the water. So there's basically no acid left in this. So this sand, which is still wet, was transferred to a baking pan and now must be dried in the oven. So we'll turn on the oven to about probably 300 Fahrenheit or something, and make sure to boil off all the water so it's nice and dry. And then we can move on to the next step. Now, this is not the most pure sand, and if you can find whiter sand, that will be good, because this is not very pure. But that is okay, because there's still plenty of silicon dioxide, and I'm hoping this will still work. But the whiter the sand that you have, the better. Even after acid washing, this still looks pretty dirty. So I'll go ahead and dry it, and then show you the next step. Okay, so after drying the sand in the oven, you can actually see it's not too bad. It does look rather white, and it's definitely cleaner than before. I also threw it through a strainer to get rid of any of the larger particles. Anyhow, so the ratio that we typically use for this reaction that we're about to carry out is, because this is impure, we're going to be, for every 1 gram of impure silicon dioxide, we're going to use about 1.33 grams of sodium hydroxide. So, this sodium hydroxide was simply bought at Home Hardware and is called lye crystals. You can buy several pounds of this for a fairly cheap price, and it's extremely useful. And you can probably find it at various different stores. It's not just as lye crystals, you can also find it as drain cleaner and various other sources. Anyhow, so we simply need to turn on our scale and zero out the pan. And I think I'll just weigh out, to make this simple, we'll weigh out 100 grams of our nice dry sand, which means that we will have to weigh out 133 grams of our sodium hydroxide. So, I'll weigh out those two things and put them together and show you what's happening next. Okay, so we just started the gas stove outside because this reaction is going to require excess of 350 degrees Celsius to melt this sodium hydroxide here. So I weighed out 133 grams and I just sealed it off so it doesn't absorb moisture while we're just waiting for the to get ready for the reaction. So, this does need at least 350 degrees Celsius to work, because we have to melt the sodium hydroxide, and that will help increase the reactivity of it while it dissolves our silicon dioxide sand. Now, I did run this through a coffee grinder quickly, just to powderize it a bit better, so that it's much more finer and hopefully the reaction works better. So we can then put it on our burner, and this pan must be made of entirely stainless steel. Nothing else. Other things can be dissolved by sodium hydroxide. It must be stainless steel. So I will write up the reaction of what's happening in a moment. But first we're just going to start this. So, we're just going to evenly disperse our sodium hydroxide around there. And I will go ahead and get something to mix it around with. And we'll mix it around and the reaction will start to occur. And so I'll meet you back in a moment. So our sodium hydroxide is now melting and undergoing the following reaction, which I've written out. So, we have 2 sodium hydroxides plus silicon dioxide, which is sand, which gives sodium silicate, and I just wrote the O in orange here because it came from this one, and water, which goes off as a gas because of the high temperatures. And then this is just simplified to Na2SiO3, sodium silicate. So this is what will be left over, as well as excess sand, and any impurities that didn't dissolve, and most likely still some sodium hydroxide. Luckily though, we should be able to, because sodium silicate is soluble in water, so after we make the sodium silicate, we'll just take everything, throw it in water, and filter off any excess impurities which will not dissolve, leaving us with a fairly pure solution of sodium silicate, and then ready to go on to the next step of purifying it. So, I'll just continue to mix this until it's all liquidy and all kind of a liquid that's been melted and mixed together really, really well. And at that point, I'll be back. Okay, so at this point, it appears that almost everything's reacted. It got to a point where it was very viscous and slurry, and then it hardened up. This is because now all we have left is sodium silicate, a bit of sodium hydroxide that perhaps didn't react, and a bit of sand that also perhaps didn't react. So, we can now go ahead and transfer all of this into some other sort of thing, such as a large beaker or a large canning jar or something. So I'm going to take this off heat, move it all to a different container, and then I'll meet you back for the next step. Okay, so after that, I ground it up in this coffee grinder here, similar to before, or a magic bullet, sorry, it's not a coffee grinder. And so it was a bit more of a powder, so it would dissolve faster. Now, sodium silicate is much more soluble in hot water, so I thought, oh, well, I'll boil some water and then add it. So that's exactly what I did. And an extremely violent reaction occurred, and this may be due to residual sodium hydroxide reacting with it as it hydrates, which releases a lot of heat, or I couldn't imagine what else. There could be lots of other reactions which are happening for this. So perhaps try cold water first, and then move on to other hot water. See, you can see it's going to start boiling as I expose the lower. So it must be the sodium hydroxide reacting with the water, forming all this heat, because believe me, it is hot. Anyhow, so we'll go ahead and top this up with water to about here to dissolve as much of the sodium silicate that was formed as possible. Then I'll meet you back. Okay, so it's extremely hot, and I'm not totally exactly sure what's happened. You can see we have some sort of precipitant cloud which has formed. I'm not sure if it's a precipitant or just a suspension of the fine particles. I'm not exactly sure. I don't think a precipitant should have formed, but then again, you never know. Anyhow, it is important to notice that if we do have sodium silicate in solution, it is also extremely basic as well as sodium hydroxide. So this is a highly basic solution. So if we were to go and get this on our skin, it would probably burn our skin. So you do have to be extremely careful. Anyhow, so the next step to do is perhaps if this is just a precipitant or some sort of suspension, we'll just let it settle out, and then we will go ahead and filter it off. And upon filtering everything off, we should have a solution of our sodium silicate and sodium hydroxide if there was any present. So we'll go ahead and do that and meet you back. And make sure to let your solution cool down to room temperature before you proceed to the next step after filtering, because we do not want to add acid to this very basic solution when it's still hot, as it could get an even more violent exothermic reaction occurring. So I'll go ahead and do that and meet you back. Okay, so now that we've filtered everything off, you can see that we're left with this totally clear solution, although it is discolored. But that's totally fine. It's probably just impurities which were dissolved into the water, but we'll be getting rid of these as we turn it back into silicon dioxide. So the next step is actually to turn this to silicic acid. And this can be done simply by adding a strong mineral acid, something like hydroiodic, hydrobromic, hydrochloric, sulfuric. Any of those acids will most likely work. And there's probably some others. So I'm not actually sure of the concentration of sodium silicate that we have in solution currently, because I wasn't sure how much we made. Now you could boil this down to figure out exactly how much hydrochloric acid or sulfuric acid or whatever you would need. However, that is an additional step, and boiling this down could be a pain in the butt. So alternatively, I'm just going to top this up to probably about here with some hydrochloric acid. I think I'll try that first and perhaps go to other acids if it doesn't work. So I'll top it up to here with hydrochloric acid, and we will be forming sodium chloride in solution and silicic acid, which may stay in solution or may precipitate out. I'm not totally sure. So we'll go outside and start adding the hydrochloric acid. It's just going to be 30-something% that we bought at Home Depot. It's called muriatic acid. I'll show you in a moment. Okay, so we're outside now, and here's the hydrochloric acid. Just muriatic acid, you can buy this at Home Depot. and it's really good. I'm almost out though, so I should buy more. Now, it is important to note that if there is excess sodium hydroxide in solution, the neutralization of the sodium hydroxide will be a very exothermic reaction. This will heat up significantly. This is why we cooled our solution down. It is at room temperature currently. Also, I'm not totally sure, but the displacement reaction of the hydrochloric acid with the sodium silicate could also be exothermic, so this should be added slowly and with caution. And we'll see if we note any changes as we add it. So I'll just start adding some. It doesn't really matter how much. Oh yes, you can clearly see that we're actually precipitating out our silicic acid. It's actually as a solid, which is very interesting. So I'll add some more. And we're certainly getting a lot of silicic acid precipitant. I'll add a bit more and see. We did indeed get more. So I'll just keep adding this till it looks like no more precipitant is forming. And I'll meet you back after that. So after stirring, a vigorous amount of bubbles were produced and it almost boiled over, but luckily it didn't. And also all of our precipitant seems to have perhaps redissolved, or maybe just more of a suspension as I broke up the chunks. But nonetheless, the next step to do is just to filter it. So we have a larger jar here, and we'll filter it through this filter paper. And all the silicic acid that is currently in solid form should be stuck in the filter paper. Then, because that silicic acid will be much more pure, we can then take our solution, which will be down here, and boil that down. Because it will only contain, impurities, which we don't want, but silicic acid and sodium chloride, if there is any silicic acid left dissolved in the solution. So, upon filtering it off, we can then boil down our lower aqueous layer to obtain the two salts, and I'll show you how to separate those. And then the top layer, which is much more pure silicic acid, so we can just move to the next step. I'll show you that all in a moment. So I'll quickly finish up filtering this and write up the chemical equation of what just happened when we added that hydrochloric acid. Okay, so if you do have a vacuum filtration apparatus, definitely use it, because this filtration is going to take days. It's filtering so slowly, and I have a lot of solution to go through. If you don't have a vacuum filtration apparatus, I do recommend boiling down your solution of sodium silicate before you add the hydrochloric acid, so that it's less liquid that you have to filter off. Anyhow, as expected, this was a fairly exothermic reaction, so it is quite hot, so it is a good idea to let the solution cool down from the previous step. Now, the reaction that happened before was as follows. So we have 2 hydrogen chloride, which is aqueous hydrochloric acid, plus sodium silicate, which gives us 2 sodium chloride, and silicic acid, H2SiO3. So this appears to have precipitated out quite well here. The camera's not really picking it up too well, but I can clearly see the silicic acid gel complex type stuff, which has formed. So I'll finish filtering off all of this, and then I guess I'll let the silicic acid go out and dry. So I'll meet you back in a moment. Okay, so as you can see, it's been a day and a half or so, and everything's been filtered through fairly well, and you can see this one actually has a dead fly in it, which is kind of interesting. Anyhow, these are extremely acidic solutions here, so we're going to need to wash them. So now that we've gotten rid of most of the hydrochloric acid excess and it's in the bottom, we can take each of these filters containing our silicic acid and put it back into the jar over there. So we'll put it all back into the jar and fill it with lots of water to dilute it, and filter once again just to remove, dilute the acid more before drying it, because upon putting it in a steel pan, if we heat it up in a steel pan, it will start dissolving the steel pan, and the acid, when it's boiled off, will also release dangerous hydrogen chloride gas. So the first thing we definitely want to do is dilute this as much as possible. So I'll move it over to this jar, and then we'll dilute it. Okay, so after removing all that silicic acid, we're left with 2 containers. Of course, our silicic acid container, which has been filtered off, and then our waste liquid, which mostly contains sodium chloride and a bit of hydrochloric acid, and perhaps still some sodium silicate, which could be converted to silicic acid. And a way to test that is just to drop in a bit more hydrochloric acid, and if any more precipitates out, then you know there's more. Ignore what I said earlier about boiling it down, then decomposing it to sodium silicate, and then silicon dioxide, and then actually removing all the sodium chloride by just dissolving it. That would take way too long. So I came up with an idea with our silicic acid here. It's not soluble in water, it appears. So upon adding a bunch of water such as this, we could dilute it. However, if we put some sort of base such as sodium bicarbonate, which is baking soda, we can effectively neutralize the acid and form water-soluble compounds, which will be the sodium chloride, and we'll be able to filter off our silicic acid and have a neutral solution, which is exactly what we need. So, now, you can see a generous amount of bubbling will be produced as the acid is neutralized, but we can just add in this solution, and it will neutralize it. So we'll be back when I'm done adding in this sodium bicarbonate solution. Okay, so I just thought of this, but I started filtering, of course, to filter off all of our silicic acid. Now, sodium bicarbonate neutralizes most acids, and I'm not totally sure about silicic acid, but we may have just neutralized our silicic acid back into sodium silicate. I really hope that's not the scenario, but it may be, and we may have to repeat the step with hydrochloric acid. And anyhow, I'll figure out what happened in a moment. Of course, after this is done filtering, we can simply check to see if we actually have any sodium silicate back in solution by just adding a bit more hydrochloric acid. So I'll let this filter and meet you back. Okay, so you can see that after filtering off that mixture again, we simply transferred it to this dish and heated it up in the oven to about 400 degrees Fahrenheit. This decomposed all of that silicic acid into silicon dioxide and water, and I will write up the equation for that in a moment. And you can see we're left with this nice white powder. However, it's still highly contaminated with various salts, such as sodium chloride, and probably still some sodium bicarbonate, which we use to neutralize the hydrochloric acid. I'm not 100% sure that this is actually silicon dioxide yet, because we still may have neutralized the silicic acid with that sodium bicarbonate, but if it's really easy to test if it is, and we will be doing this in a moment to purify it. So, as I read of the reaction, what we're going to do is transfer this to a blender or something, strictly used for science, and grind everything up into a nice fine powder. Then I'll show you what to do next. Okay, so I just put it in this magic bowl and ground it up. And here's the reaction of the decomposition when we heated up our silicic acid. So we have silicic acid, which when heated up turns into silicon dioxide and water, which goes off as a gas. So the silicon dioxide, which is still contaminated because we haven't done anything to it, is now ready to be purified. So it's in a powdered form. Now, I've always wanted to say this because it's very cool, and the longest word in the English dictionary actually applies to this topic. So, when inhaling fine silica dust, as this silicon dioxide, another name for it is silica. If you inhale very fine silica dust as this, it can cause a disease known as pneumonial ultramicroscopic silicon volcanicoleosis. And yes, it is a real thing, Google it. And basically what it does is it causes microscopic cuts in your lungs and seriously harms your health. So do not breathe in silica dust. Now, with that said, let's move on to the next step. Anyhow, so we're basically going to take this nice powder and throw in about this much water, and then mix it up some more. Alternatively, if you do not have a blender that you can use, you can just do this by hand and mix it up really well. But I'll be using a blender to get a more equal mix. By adding the warm water, it will help dissolve all the soluble impurities, such as the sodium bicarbonate, sodium chloride, and any other soluble impurities. And all that should be left is our silicon dioxide, which is insoluble in water. So I'll go ahead, add the water, and mix it up. Okay, so after that, I simply just filtered it off and dried it in the oven. And upon drying it in the oven, I just crumbled it into a fine powder. And you can see that we're left here with this nice fine powder of silicon dioxide. So you can see it's extremely white and very pure. I weighed this, and this is exactly 20 grams of silicon dioxide, which means that we got about 20% of our original 100 grams of sand converted to silicon dioxide. Now, this is perhaps somewhere around a 50% yield. I can't actually be sure because I don't know how much silicon dioxide my sand actually contained, as there was certainly a lot of impurities in it. But nonetheless, you can see that it's relatively, actually quite very pure silicon dioxide here. And some things that we'll be using this for is to make silicon metal, or well, it's a metalloid, but elemental silicon through the reduction with aluminum. And I also plan on reacting this with sodium hydroxide, making sodium silicate, so that we can do a reaction known as a chemical garden, which is where you drop transition metal salts into a solution of sodium silicate, and very cool things happen as the insoluble metal silicates precipitate out. Anyhow, so there's a few applications you can do with this, so I highly suggest you purify some sand into this nice silicon dioxide. Hope you guys enjoyed. Wait, bye.